Welcome, YouTubers, to another episode in my Grammar Hero series. In today's video, I'm going to be working out 16 practice test questions that should prepare you for the arithmetic reasoning subtest of the Armed Services Vocational Aptitude Battery, that is the ASVAB, as well as the pre-screening Internet Delivered Computer Adaptive Test, that is the PiCAT. In order to get the most out of this practice test, you'll want to pause the video after I read a question. Attempt to work out the question on your own, and then resume playing the video to check your solution. As a reminder, you're not permitted to use a calculator or a reference sheet on the actual ASVAB or PiCAT, so as you work your way through these practice questions, try not to use any of those resources. Finally, I want to mention that in the description of this video, there will be timestamps associated with each question. Next to the timestamp will be the topic that the question's testing, as well as a link to one of my videos where you can learn more about that topic. So if at any point in this video you feel as if you need more help, just check out the description of this video, and there you'll find links to my additional resources. So with all those things being said, let's go ahead and get started with this practice test. All right, so number one says to mail a package in Dusseldorf, Germany, it costs $5 plus an additional 5 cents for every ounce a package is over 6 ounces. If a package weighs 2 pounds and 4 ounces, then how much will it cost to mail it? All right, so the first thing we have to do is we have to take the weight of our package, notably 2 pounds and 4 ounces, and we have to convert that to be only in terms of ounces. So again, we're going to take our 2 pound and 4 ounce package, and we're going to convert that to be just in terms of ounces. If you've reviewed my reference sheet, which you can download for free from my website, you know that 1 pound is equal to 16 ounces, and we're going to need that to make this conversion. Again, if 1 pound is 16 ounces, then 2 pounds is going to be 16 times 2 ounces. 16 times 2 is 32, but if you couldn't do that mentally, you could do this the old fashioned way. 6 times 2 is 12, so drop down a 2, carry a 1. 1 times 2 is 2, plus 1 is 3. So this is the same thing as 32 plus 4 ounces, which is the same thing as 36 ounces. All right, so we know our 2 pound and 4 ounce package is the same thing as just being 36 ounces. All right, so now we're going to figure out how much it's going to cost to mail our 36 ounce package. And we have to go back and take a closer look at what this problem says. It says it costs $5 plus an additional 5 cents for every ounce the package is over 6 ounces. All right, so we have to figure out how many more ounces our package is than 6 ounces. That's pretty easy to do. We know our package is 36 ounces. From that, we'll subtract 6. 36 minus 6 is going to be 30. All right, again, cost 5 cents for every ounce a package is over 6 ounces. Our package is 30 ounces over 6 ounces. So we're going to have to do 30 times 0.05 to figure out how much that's going to cost extra. And as you can see, we're multiplying a whole number, notably 30 by a decimal, notably 0.05. To proceed, you want to take this decimal in 0.05 and shift it 2 times to the right, if my pen will let me write it, such that this problem becomes 30 times 5 with no decimal. And once we work this out, we'll take our 2 decimals that we shifted to the right here, and we'll shift them back into the left. All right, so 5 times 0 is 0. 3 times 5 is going to be 15. Bring our 2 decimals back in, 1, 2. So clearly, we're going to have to pay an additional fee of $1.50 for our 36 ounce package. So again, we're paying a flat rate of $5 plus an additional rate of $1.50 since our package is 30 ounces more than the 6 ounce limit. And let's just add these together. 0 plus 0 is 0. 0 plus 5 is 5. Drop down your decimal in place. 5 plus 1 is 6. So in total, we're going to have to pay $6.50 to mail our package. All right, so quite a bit of work with decimals there. In addition, we had to convert pounds and ounces to be just in terms of ounces. But apart from that, this problem was pretty simple and straightforward. So number 2 says, during the holiday season, a pair of shoes that normally cost $90 were marked down by 25%. What was the sale price of the shoes? So to find the sale price of these shoes, we're going to take the original price of the shoes, and from that, we're going to subtract out the discount amount times the original price. Of course, we know what all these things are already. The original price of the shoes, according to the problem, is $90, so that's going to be our OP. And we know uh, they were marked down 25%. So our discount amount in this case is going to be 25%, but more often than not, you're going to express percents in decimal form for word problems. So the decimal equivalent of 25% is 0.25. Now that we've identified those two things, let's just go ahead and plug them in accordingly. Again, we know the original price was $90, so this becomes 90 minus the discount amount, which is 0.25, times the original price. Again, that is 90. And once we do this simple arithmetic right here, we'll know the sale price of these shoes. Of course, we're going to do 0.25 times 90 first, and that's going to be 90 times 0.25. And as was the case in the first problem, you can see that we're multiplying a whole number by a decimal again. You want to clear this decimal by shifting it to the right however many times you need to. In this case, we're going to clear it by shifting our decimal 2 times to the right. I'm going to take note of that. And this problem becomes 90 times 25, albeit with 2 decimals to shift back into the left at the end when we're done. Again, we cleared the decimal by moving it to the right here. Once we work this out, we'll put our decimal back in our answer by shifting it to the left 2 times. All right, so let's go ahead and get started. 0 times 5, of course, is 0. 9 times 5 is 45. Before we start multiplication with this 2, we have to bring in a 0 placeholder. 2 times 0 is 0. 9 times 2 is 18. Let's add these together now. 0 plus 0 is 0. 5 plus 0 is 5. 8 plus 4 is going to be 8, 9, 10, 11, 12. So drop down a 2, carry a 1. 1 plus 1 is 2. Bring in our 2 decimals. 1, 2. So this becomes 90 minus 2250. Of course, since we're doing subtraction involving a whole number and a decimal here, it might be easier to work this off to the side like this. 90 minus 2250. Of course, you can go ahead and add your decimal in 90 as well as 2 0 placeholders, which should make this a little bit easier to do. 0 minus 0 is 0. 0 minus 5 we can't do, so we have to borrow from the left. We can't borrow from 0, so we're going to have to borrow from this 9. This will become 8, and then this will become 10. We're going to borrow one more time. This will become 9, and now this will become 10. 10 minus 5 is 5. Drop down our decimal in place. 9 minus 2, of course, is 7, and 8 minus 2 is 6. So we can see that these shoes with a 25% discount should cost $67.50, which is answer choice B. Number 3 says Jake is renting an apartment in Miami Beach for $2,800 a month. When the lease for his apartment expires next month, his landlord will increase his monthly rent by 5.5%. What will his new rent be per month? So we first have to figure out what 5.5% of 2,800 is. And that's actually pretty easy to do. We're going to take 2,800 and we're going to multiply that by 5.5%. And as we've seen in this video twice already, we're going to have to convert this 5.5% to be in decimal form. And the decimal equivalent of 5.5% is 0.055. So we're going to take 2800 and multiply it by 0.055. And as we've seen in this video, when you multiply a whole number by a decimal, what you want to do is take that decimal and shift it however many times you need to the right, such that you clear it. So we're going to shift it, in this case, 1, 2, 3 times to the right. I'm going to take note of that. This, of course, becomes 2,800 times, and we can get rid of this zero, 55, albeit with 3 decimals to move back into the left at the end. All right, so let's go ahead and work on doing that. We have 0 times 5, which is 0, 0 times 5, which is 0, 8 times 5, which is going to be 40, so drop down a 0 and carry a 4. 5 times 2 is 10, plus 4 is 14. Before we can start multiplication with that 5, we have to bring in a 0 placeholder. 5 times 0 is 0, 5 times 0 is 0. 8 times 5, of course, is 40, so bring down a 0, carry a 4. 5 times 2 is 10, plus 4 is 14. Let's add these together now. 0 plus 0 is 0. 0 plus 0 is 0. 0 plus 0 is 0. 4 plus 0 is 4. 4 plus 1 is 5. 1 plus nothing is 1. Bring our 3 decimals back in. 1, 2, 3. So we can see that 5.5% of 2,800 is $154. And we'll go ahead and take that and add it to 2,800 now. 0 plus 4 is 4. 5 plus 0 is 5. 8 plus 1 is 9. And 2 plus nothing is 2. So his new rent should be $29.54, which we can see is A. All right, so pretty simple problem there. We just took 2,800, multiplied it by 5.5%, which is 0.055 in decimal form. Then we took that amount and added it back to 2,800. All right, so that is that one. Number 4 says at 4 p.m., a man who is exactly 6 feet tall cast a shadow that is 18 feet long. At the same time, a nearby tree cast a 48-foot shadow. How tall is the tree? All right, so in this case, it might be helpful to make a quick sketch so that you can see what's going on here. According to the problem, we have a man standing next to a tree. We can go ahead and sketch a tree if we want. What's more, we know the man is 6 feet tall, and he cast a shadow that is 18 feet long. Similarly, we know that this tree, according to the problem, cast a shadow that is 48 feet long, and we don't know its height. And in mathematics, you typically represent unknown values with letter variables. So in this case, we're being asked to figure out how tall the tree is, which is an unknown. So we're going to call the height of this tree X feet. And it may not be too obvious, but when you enclose these two figures, if my pen will let me do it, what you get is a pair of similar right triangles. And as it happens, we can actually use a proportion to quickly solve this one. Um, Again, a proportion is nothing more than two fractions that are equal to each other. And the way I like to think about proportions is like this. You want to fill in the information that you have on the left-hand side of the equal sign, and on the right-hand side of the equal sign, you want to put the information you're trying to figure out. Well, what information do we have? We know that a 6-foot tall man cast a shadow that is 18 feet long. And the key here is to fill in this right-hand side the same way. Specifically, since I put the height of the man in the numerator over here, I'm going to put the height of the tree in the numerator over here. Of course, the height of the tree is unknown, so we'll call this X feet. And down here, I have the length of the shadow, so I'm going to put the length of this shadow down here. That's going to be 48 feet. To solve proportions, you use cross multiplication, so you can do 18 times x, which is 18x, equals 6 times 48. And let's go ahead and work this off to the side so as not to make any mistakes. We have 48 times 6. 8 times 6 is going to be 48. So drop down an 8, carry a 4. 6 times 4 is 24. Uh, plus 4 is going to be 28. So this is 18x equals 288. Again, we're just solving for x, which is the height of the tree. So we'll go ahead and divide both sides by 18 now. And there's a clue that 18 should go into 288 evenly. And that clue is the fact that all of our answer choices are even numbers. So I'm actually going to pull this off to the side and treat this like long division. Again, you could read this as a fraction as 288 over 18, but you could also read this as long division like 288 over 18. We start doing this long division by asking ourselves this: how many times does 18 go into 2 without going over? It doesn't. How many times does 18 go into 28 without going over? It's going to be one time, given that 18 times 1 is 18. Of course, 28 minus 18 is 10. And now let's drop down this 8. Now the question is, how many times does 18 go into 108 without going over? Well, it's either going to be 2, 4, 6, or 8 times. You should know that 18 times 2 is not going to get us very close to 108, but 6 and 4 will. So I'm going to do 18 times 6 off to the side here and see if that gets me 108. 6 times 8, as I've said already, is 48, so drop down an 8, carry a 4. 1 times 6 is 6 plus 4 is 10. So clearly 18 times 6 is 108, and 108 minus 108 is 0. That 0 means that there's no remainder, so we can see that x in this case is 16 feet. In other words, the height of this tree is 16 feet, which is answer choice C. All right, so that is that one. Nothing too difficult there. Number 5 here says, at a furniture store, a couch has a price tag of $500. Instead of buying the couch for that price, Erica set up a payment plan with the salesperson. She agreed to make a down payment equal to 25% of the price of the couch, as well as 12 monthly payments of $50 each. How much more did Erica pay for the couch because she used a payment plan? All right, so we have to figure out how much more she spent because she set up a payment plan rather than just paying $500 at once. And to do that, we're going to take this part of the word problem and translate it to something that we can work out, notably right here. 25% of the price of the couch. Well, we know the price of the couch was $500, so we have to figure out what 25% of the price of the couch was. So that's going to be 500 times 0.25. And to that, we're going to add her monthly payments as well. Right here it says she made 12 monthly payments of $50 each. So that looks like this: 12 times 50. When we figure this out, this will give us the total cost of the couch for the payment plan. So let's go ahead and work this out. I think doing 12 times 50 is easier than doing 500 times 25. So I'm going to do this first. Again, we have 50 times 12 right here. 0 times 2 is 0. 5 times 2 is 10. Before we start multiplication with that 1, we have to bring in a 0 placeholder. 1 times 0 is 0. 1 times 5 is 5. Let's add these together now. 100 plus 500 is 600. So we can see that this is plus 600. All right, let's go ahead and do 500 times 0.25 now. And of course, I'm going to work that off to the side. We have 500 times 0.25. And as we've seen in this video several times already, when you multiply a whole number by a decimal, you want to shift that decimal place such that you get rid of it completely. So we're going to take it, move it 2 times to the right. This problem becomes 500 times 25, albeit with 2 decimals to move back into the left at the end when we're done. 0 times 5 is 0. 0 times 5 is 0. 5 times 5 is 25. Before we start multiplication with that 2, we're going to have to bring in a 0 placeholder. 2 times 0 is 0. 2 times 0 is 0. 5 times 2 is 10. Let's add these together now. 0 plus 0 is 0. 0 plus 0 is 0. 5 plus 0 is 5. 2 plus 0 is 2. 1 plus nothing is 1. Bring our 2 decimals back in. 1, 2. So this is 125 plus 600. You should know that that is 725, but I will go ahead and do that off to the side so you can see it. We have 600 plus 125. 0 plus 5 is 5. 2 plus 0 is 2. 6 plus 1 is 7. All right, so the total cost for the couch, given that she used the payment plan, was $725. And the question is this: how much more is that than the original price of the couch? Again, we know the couch was $500, so we'll do 725 minus 500. And most of you could probably do this in your head, but I'll do it the old-fashioned way here. Uh, 5 minus 0 is 5. 2 minus 0 is 2, and 7 minus 5 is 2. So clearly, she had to pay an extra $225 to buy the couch using the payment plan than if she just paid for it outright. So the answer to this one is D. She spent $225 extra dollars to get the couch using the payment plan. All right, so that is that one. Number 6, as you can see, says a 6-sided die is rolled 2 times in a row. What is the probability of not rolling a 6 both times? All right, so if it's helpful, you can quickly sketch out the faces of this 6-sided die. Again, the faces of the die look like this. We have one face that has a 1 on it. We have another face that has a 2 on it. We have a third face with a 3 on it. We have a fourth face that has 4 that looks like that. Then we have a fifth face that kind of looks like this. And then finally, this die has a sixth face that looks like this. All right, so now that we have the faces of the die in our mind, let's go ahead and break this advanced probability problem down into simpler pieces. On my reference sheet on my website, you'll see that I have some notes about basic probability. And it says this: the probability of not A is equal to 1 minus the probability that it is A. Now you're probably saying to yourself, how does this apply to this word problem? And let's go ahead and rephrase this word problem such that it does. Imagine if this word problem said, what is the probability of not rolling a 6 one time? That would be this: what is the probability of not rolling a 6? That would be equal to 1 minus the probability that you do roll a 6. And that's pretty easy to figure out. 1 minus the probability that we do roll a 6. Well, when we roll this dice once, there are 6 possible outcomes in total, and only one of those is a 6. So the probability of rolling a 6 is 1 over 6. Of course, the probability of not rolling a 6 is 1 minus 1 over 6. You should know that 1 minus 1 over 6 is 5/6. Since you can write 1 as 6 over 6. Again, 6 divided by 6 is 1, minus 1 over 6 equals 5 over 6. So in other words, if you rolled this dice once, the probability that you did not roll a 6 would be 5 over 6. All right, so this problem's a little bit more advanced than that because we're told that this dice was rolled 2 times. So we actually have to use another general rule of probability to take this one step further, notably this: the probability of A and B occurring together is the probability of A times the probability of B. Well, in this case, we're trying to figure out the probability of not rolling a 6 and the probability of not rolling a 6 again. And that's going to be the probability of not rolling a 6 times the probability of not rolling a 6. And did we already figure out what the probability of not rolling a 6 is? We did. It's right here. Probability of not rolling a 6 is 5 over 6. So this simply becomes 5 over 6 times 5 over 6. And when you multiply two fractions, you simply just multiply straight across. This becomes 5 times 5 over 6 times 6. 5 times 5 is 25. 6 times 6 is 36. So the probability, in other words, of not rolling a 6 two times in a row is 25 over 36, which we can see is answer choice B. All right, so number 7 says a maintenance crew is painting a new landing stripe on a runway. As shown, sections of the runway are marked off into 10-inch squares and then into triangles. If only the triangle part of the squares will be painted, how much area will each painted triangle cover? All right, so they gave us a small diagram for this problem. As you can see, we have a triangle inside a square. And according to the problem, we want to figure out what the area of this painted triangle is. Of course, you have to know that to find the area of any triangle, you always use the formula area equals 1/2 base times height. And the difficult part about this problem is the fact that you're not given the base or the height of this triangle directly. Instead, you have to use your knowledge of the properties of squares as well as triangles to figure that out yourself. The first property you have to know is that in squares, all the sides are equal. So that side is equal to that side's equal to that side, and that side's equal to that side. Well, we know this side is 10 inches, so that means this side's 10 inches, this side's 10 inches, and this side's 10 inches. And clearly, uh, from here to here is the base of our triangle, and you should know that that is going to be 10. All right, so the base of this triangle is 10. Finding the height of this triangle is slightly more challenging. You have to know that the height of the triangle is always the distance from the apex, or the highest point in the triangle, which is right here, straight down in a straight line to the base. So that's from here to here in a straight line. And we should see that that is the same distance as the side length of this square. So the height of this triangle is also 10. So now that we know the base and height of this triangle, this problem becomes very easy. We can go ahead and plug those two values into our formula over here. This becomes 1/2, base is 10, so this is 1/2 times 10. Height, of course, is 10. All right, doesn't matter how you work this out. I'm going to do 10 times 10, which you should know is 100, so this becomes 1/2 times 100, and 1/2 of 100 is 50. Of course, we're talking about the area of this painted triangle, so that's going to be 50 inches squared. All right, so the area of each painted triangle on this runway is 50 square inches, which is answer choice B. Number 8 says, if a square coffee table has a perimeter of 20 feet, what is the area of the coffee table? All right, so before I even get started working my way through this one, I want to mention this. As far as squares go, if you know the perimeter of a square, you can easily figure out what its area is. Similarly, if you know the area of a square, you can easily figure out what its perimeter is. And in this case, we were given the perimeter of a square and we want to figure out what its area is. So let's think about how we're going to do that. First, let's make a quick sketch to represent our square coffee table. And you should know some properties of squares, notably that all the side lengths in a square are equal. So this side's equal to this side, that side's equal to that side, and that side's equal to that side. This problem told us that this coffee table had a perimeter of 20 feet. Well, how do you find the perimeter of a square? You simply add up all of its sides. Well, in this case, we don't know the lengths of the sides of this square, so we can call the side lengths S. This is S, this is S, this is S, and this is S. Again, to find the perimeter of a square, you just add up all of its sides. So this is S plus S plus S plus S. We know what P is. The problem told us P is 20. So in place of P here, let's go ahead and put 20. And this becomes S plus S plus S plus S, which is 4S. Let's go ahead and solve for S so we know how long each of the sides of this square is. Let's divide both sides by 4 to do that. This crosses out, leaving you with S on this side. 20 divided by 4 is going to be 5. So the side lengths of this square are 5. Well, how do you find the area of a square? To find the area of a square, it's simply S times S. We now know that S is 5, so this becomes 5 times 5. 5 times 5 is 25. Of course, this is going to be feet squared. So the area of a coffee table that has a perimeter of 20 feet is 25 feet squared, which is answer choice B. We'll go ahead and put the squares on these since I did not do that. Number 9 says Stephanie has two cardboard boxes. The height of the second box is 1/3 the height of the first box. The lengths and widths of the two boxes are the same. If the first box has a length of 10 inches, a width of 5 inches, and a height of 12 inches, then how much more volume does the first box have than the second box? So clearly, we're comparing the volumes of two boxes, and boxes are nothing more than rectangular prisms. How do you find the volume of a rectangular prism? It's always length times width times height. It's very simple to remember that. So since we're comparing two volumes here, I'm going to say the volume of this first box is length times width times height. And the volume of this second box is length times width times height. Let's go ahead and find the volume of this first box. Again, we're told that the first box has a length of 10, so this becomes 10, a width of 5, so that's 5, and a height of 12. Let's go ahead and work this out. Um, you should know that 5 times 12 is 60, and 60 times 10 is going to be 600. So the volume of this first box is 600 cubic inches. All right, let's find the volume of this second box now. According to the problem, uh, the lengths and widths of the two boxes are the same. So our first box had a length of 10 and a width of 5. So the length and width of our second box are going to be 10 and 5. Then it says the height of the second box is 1/3 the height of the first box. Well, we know the height of this second box is 12. So we got to figure out what 1/3 of 12 is. So we can do 12 times 1/3 like that. Of course, we can write 12 as a fraction by placing it over 1 and then multiplying straight across. This becomes 12 times 1, which is 12, 3 times 1, which is 3. 12 divided by 3 is 4. So the height of our second box, which is 1/3 of the height of our first box, is clearly 4. Let's go ahead and work this one out. This is actually pretty easy to do. You should know that 5 times 4 is 20. 20 times 100 is going to be 200 inches cubed. And the question is this: how much more volume does the first box have than the second box? So that's simply going to be 600 minus 200, which you should know is 400. So clearly, this first box has 400 cubic inches more volume than the second box, which is answer choice D. So number 10 says Anderson is paid $15 per hour to mow his parents' lawn. On Saturday, he started mowing the lawn at 10 a.m. and finished mowing it at 11:50 a.m. How much will his parents pay him for his work? All right, so the first thing we have to figure out is how long he spent in total mowing his parents' lawn. You should know that between 10 a.m. and 11:50 a.m., that's going to be an hour and 50 minutes. But if you couldn't do that mentally, you could always work it out the old fashioned way by saying he started at 10 a.m. If you add an hour to that, that will bring you to 11 a.m. And if you add 50 minutes to that, that will bring you to 11:50, which is when he finished mowing the lawn. So in total, he spent 1 hour and 50 minutes mowing the lawn. And some of you might be saying to yourself, well, we're going to take that 1 hour and 50 minutes and multiply it by his hourly rate of $15 per hour to figure out how much he's owed in total. And of course, that's what you would do. But that said, how are you going to multiply 15 by 1 hour and 50 minutes? Clearly, we have to convert this 1 hour and 50 minutes to be a fraction, which will make this math a little bit easier to do. So I'm going to write this 1 hour as my whole number, and then I'm going to convert this 50 minutes to be in terms of hours as well. Again, there are 60 minutes in an hour, so we know that 50 minutes is 50 minutes over 60 minutes, and we can cross out these corresponding zeros. In other words, 50 minutes is 5/6 of an hour. So 1 hour and 50 minutes is the same thing as 1 and 5/6. And now we can go ahead and multiply that by his hourly rate of $15 per hour. Of course, now we're multiplying a mixed number by a whole number. In order to proceed, it might be easier to convert this mixed number to an improper fraction. You could do 1 times 6, which is 6, plus 5 is 11. So this is 11 over 6 times 15. And now let's go ahead and write 15 as a fraction by placing it over 1. And this is going to enable us to multiply straight across. Again, when you multiply fractions, you multiply straight across. So this becomes 11 times 15 over 6 times 1. Um, Before we do 11 times 15, we can actually make this math a little bit easier. We can say 3 goes into 6 2 times and 3 goes into 15 5 times. So this becomes 11 times 5, which is 55, over 2 times 1, which is just 2. All right, so let's go ahead and try to convert this to be back in terms of a whole number in decimals if needed. We can see that all of our answers have decimals in them. And to do that, we're going to take this improper fraction and we're going to treat it like long division. Specifically, we're going to read it as 55 divided by 2. And this should be pretty easy to work out. We start by asking ourselves, how many times does 2 go into 5 without going over? Well, 2 times 2 is 4. 5 minus 4 is 1. Drop down this 5. Now the question is, how many times does 2 go into 15 without going over? 2 times 7 will be 14. 15 minus 14 is 1. And since 2 does not go into 1, we have to realize that we have a decimal here, which we can bring up into our answer, and a 0 placeholder here, which we can now drop down here. How many times does 2 go into 10? 2 times 5, of course, is 10, and 10 minus 10 is 0. Since we hit this 0, we know we're done. So 55 over 2 is the same thing as 2750. Of course, we can write that with a dollar sign to be 2750. In other words, Anderson's parents will have to pay him 2750 for mowing their lawn. I wonder if he lives there too. All right, so that is that one. Number 11, as you can see, says the price of gas in California is $4.40 per gallon. This is 110% of the cost of gas in Florida. How much does gas cost per gallon in Florida? All right, so thankfully, this problem tells you exactly what to do. And in case you're wondering, the goal in this problem is to take this word problem and translate it into an equation that we can then solve. So let's work on doing that. It says right here, the price of gas in California is $4.40 per gallon. So I'm going to write down 440. We know that's the price of gas in California. Says this is 110%. Well, in math, is always associated with equals. So 440 equals or is 110%. Well, as I've said in this video multiple times already, we're going to express percents more often than not as decimals, and the decimal equivalent of 110% is 1.10. So this is going to become 440 equals 1.10, 110% of the cost of gas in Florida. Well, in math, we typically associate the word of with multiplication. So this becomes 110 times the cost of gas in Florida. How much does gas cost per gallon in Florida? Well, that's an unknown. And as I've said in this video already, we typically represent unknowns with letter variables in mathematics. So I'm going to let X refer to the cost of gas in Florida. This becomes 440 equals 110 times X, where X refers to the cost of gas in Florida. And clearly, that's what we're trying to figure out. So we're going to be solving this simple equation here for X, which means when everything's said and done, it's going to look like this. X equal to something by itself. Let's go ahead and divide both sides of this equation by 110 to get X by itself. This crosses out here, leaving you with just X on this side. And of course, X equals 440 over 110. Now, many of you probably already know what that is, but that said, if this math was a little bit harder, you would actually have to work this out. Specifically, you would read this as 440 divided by 110. And as you can see, we are dividing two decimals, one of which is outside this division bracket. If you watch my video on decimals, you would know that in order to proceed, we have to clear this decimal in the number that's outside this division bracket by shifting it to the right. So we're going to take it, we're going to shift it two times to the right, and that's going to become 110. And at the same time, we have to take the decimal in 440 and shift it a corresponding number of times. So that's going to be 1, 2. That becomes 440 like that. And your answer choices in this case will be a big clue as to how you're going to figure this one out. Again, our answer choices are 4, 395, 385, and 375. Well, you should know that 110 times 4 is 0 times 4 is 0, 1 times 4 is 4, 1 times 4 is 4. So 110 times 4 is in fact 440 with no remainder. 440 minus 440 is 0. All right, so X in this case is 4, and we can go ahead and write it like this. X is 4 are $4. All right, so the cost of gas in Florida is $4, which is answer choice A. All right, so that is that one. So number 12 says, if the population of Butte, Montana increased by 15% in 10 years, then its new population is what percentage of its old population? All right, so let's go ahead and try to represent what's being asked in this question algebraically. We know that we're going from the original population of Butte, Montana, which I'm going to call P of O. We're told that in 10 years, it increases by 15%, and it has a new population, which I'm going to call P of N. And we have to figure out what percent the new population is of the old population, and that's going to be this P of N over P of O. Now, the most challenging aspect of a problem like this is the fact that we don't know what P of O is, and we don't know what P of N is. So the key here is to come up with values on your own, such that this math is actually very easy to do mentally. So we weren't told what its original population is. So I'm going to say its original population was 100 people. Now we have to figure out what 15% added to 100 people is, and that's pretty easy to do. Plus 15% of 100 is going to be plus 15 people, which means that its new population is 115. Now you could work that off to the side. You could say 100 times 0.15 is 15, and then you can add that to get 115. But again, the goal here is to use numbers that make this mental math very easy to do. And now we know both P of n and P of O. P of n is 115. P of O is 100. And 115 divided by 100 is going to be 115%. All right, so the answer to this one is C, 115%. Again, this problem would be very difficult if you selected a value for P of O that you couldn't work with mentally. So I'm not going to work this one out in greater detail. If you can't do 0.15 times 100 mentally, you need to go back and watch my video on decimals. Similarly, if you didn't know that 115 over 100 is 115%, you got to go back and watch my video on percents. Again, 75 over 100 would be 75%. So 115 over 100 is 115%. So get good at mental math. It's going to help you quickly solve problems like this one on the actual test. So number 13 says an Acme computer chip can process 100,000 gigabytes of data in 20 minutes. An IBEX computer chip can process 120,000 of gigabytes of data in 40 minutes. How many more gigabytes per minute does the Acme computer chip process than the IBEX computer chip? All right, so clearly we're going to be comparing two rates of work that these computer chips can do. But that said, it wants us to compare the rate of work that they can do per minute, but we're only given the rate of work per 20 minutes for the Acme computer chip and per 40 minutes for the IBEX computer chip. So let's start with the Acme computer chip and let's figure out how many gigabytes of data it can process in 20 minutes. We know it does 100,000 gigabytes of data in 20 minutes. So if we do 100,000 divided by 20, that will tell us how many gigabytes of data it processes per minute. And of course, this math's actually very easy to do. We can cross out these corresponding zeros here, and this becomes 10,000 divided by 2. And you should know that 10,000 divided by 2 is going to be 5,000. All right, so in other words, this Acme computer chip can process 5,000 gigabytes of data per minute. All right, now let's go ahead and you do the same thing for the IBEX computer chip. And according to the problem, it can process 120,000 gigabytes of data every 40 minutes. All right, so let's go ahead and work on converting this to be a rate per minute. Of course, we can cross out these corresponding zeros, and this becomes 12,000 divided by 4. You should know that 12 divided by 4 is 3, and then we can just tack on these 3 zeros. In other words, this IBEX computer chip can process 3,000 gigabytes of data per minute. All right, let's go back and see what this question was asking. It wants us to figure out how many more gigabytes per minute does the Acme computer chip process than the IBEX computer chip. So that's simply going to be 5,000 minus 3,000, which you should know is 2,000. In other words, this Acme computer chip processes 2,000 more gigabytes of data than the IBEX computer chip. So the answer to this one, of course, is B. So number 14 says, after moving into a bigger house, a woman wants to buy a larger square dining table. In an antique store, she found a dining table that has 3 times the area of her current dining table. If the perimeter of her current dining table is 20 feet, how many square feet is the dining table she's looking at in the store? All right, so there's a lot going on in this problem, but at the end of the day, you have to realize this again. If you know the perimeter of a square, you can find its area. Likewise, if you know the area of a square, you can find its perimeter. So let's start by thinking just about the size of the woman's current dining table. Okay, we know according to the problem, it's in the shape of a square. And as I've mentioned multiple times in this video, squares have side lengths that are all equal. Well, we know the perimeter of her current dining table is 20 feet, so we're going to say P is 20. We don't know how long each of its sides is. That said, in math, we represent unknown side lengths of squares with the letter S, so this becomes S, 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 and S. Of course, to find the perimeter of a square, we simply add up all of its sides, so that becomes S plus S plus S plus S. Again, we know what P is, so let's go ahead and plug that in. This becomes 20 equals S plus S plus S plus S is going to be 4S. If we solve this for S, we'll know how big her current dining table is. So let's divide both sides by 4. This crosses out, leaving us with S on this side. 20 divided by 4 is 5. So S is 5 in this case. So her current dining table looks like this. It's a square, and all of its sides are 5 feet long. Well, right here it says uh, the table she found in the store has 3 times the area of her current dining table. Well, what is the area of her current dining table? Well, to find the area of a square, that's always going to be side times side. And we know what the side length of her current dining table is. It's 5 feet, so that becomes 5 times 5. In other words, her current dining table has an area of 25 square feet. And again, right here it says the dining table she's looking at in the store has 3 times the area of her current dining table. Her current dining table has an area of 25 square feet, so we'll take 25 and we'll multiply that by 3. 3 times 5, of course, is 15. Drop down a 5, carry a 1. 2 times 3 is 6 plus 1 is 7. So the dining table that she's looking at in the store must have an area of 75 square feet, which is 3 times the area of her current dining table. Number 15 says at the John F. Kennedy International Airport, a fueling truck can fill a tank with jet fuel at the rate of 2,500 cubic inches per minute. If a rectangular gas tank is 20 inches long, 15 inches wide, and 10 inches tall, how long will it take the fueling truck to fill this tank? All right, so in this problem, there's a very big clue as to how you're going to get started. And that clue's right here. The rate at which this fueling truck can fill up tanks. It's 2,500 cubic inches. That is inches raised to the third power. When you're dealing with cubic inches or cubic feet or cubic anything, that lets you know that you're going to be working with volume. Specifically, we're going to be working with the volume of this rectangular gas tank. And you should realize that a rectangular gas tank is the same thing as a rectangular prism. And as I've mentioned in this video already, to find the volume of a rectangular prism, it's always length times width times height. And thankfully enough, we have all those things. According to the problem, the length of this gas tank is 20 inches, its width is 15 inches, and its height is 10 inches. So let's go ahead and find its volume. We can do 15 times 10 pretty quickly. 15 times 10 is 150. And if you don't want to work this out mentally, you can always do it off to the side like this. This is 150 times 20. 0 times 0 is 0, 5 times 0 is 0, 1 times 0 is 0. Before we start multiplication with this 2, we have to bring in a 0 placeholder. 2 times 0 is 0, 5 times 2 is 10, so drop down a 0 and carry a 1. 1 times 2 is 2 plus 1 is 3, so this is 0 plus 3,000, which is just going to be 3,000. So the volume of our fuel tank is 3,000 cubic inches. Now, to figure out how long it's going to take this truck to fill up our gas tank, we're going to take the volume of our gas tank, which is 3,000, and we're going to divide it by the rate at which this truck can fill up gas tanks, notably 2,500 cubic inches per minute. Let's go ahead and cross out these corresponding zeros. This becomes 30 over 25. And you should recognize that both 30 and 25 have a common factor of 5. So we can reduce this a little bit further. 30 divided by 5 is 6. 25 divided by 5 is 5. So, in other words, it will take this truck 6/5 of a minute to fill up our gas tank here. But unfortunately, all of our answer choices are given in terms of minutes and seconds. So in other words, we're going to have to take this 6/5 of a minute and convert it to be in terms of minutes and seconds. The first thing you want to do here is convert this improper fraction to mixed number by doing some simple long division off to the side. Again, I could read this as 6 divided by 5. 5 goes into 6 one time without going over. 1 times 5 is 5. 6 minus 5 is 1. So we can go ahead and write this as a mixed number now. This 1 is going to be our whole number. This 1 down here is going to be our numerator. And this 5 is going to be our denominator. So now we can see it's 1 and 1/5 of a minute. So we got to figure out what 1/5 of a minute is. Again, in a minute, there are 60 seconds. So we'll take 60 seconds. We'll multiply that by 1/5 now. Uh, to do this math, notably 60 times 1/5, we can write 60 as a fraction by placing it over 1. And then that enables us to just multiply straight across. 60 times 1 is 60. 1 times 5 is 5. You should know that 60 divided by 5 is 12. So this 1 and 1/5 of a minute is the same thing as 1 minute and 12 seconds. Again, 1/5 of a minute is 12 seconds. And we can see that the answer, of course, is a 1 minute and 12 seconds. All right, so that is that one. Pretty challenging, but nothing too difficult there. All right, so number 16 says a steamboat can go 3 times as fast downstream as it can go upstream, and 1/2 as fast upstream as it can go in calm water. If it can go 15 miles per hour downstream, then how long will it take to travel 40 miles in calm water? You should recognize that this problem has all the elements that you need for the distance formula. Again, the distance formula describes the relationship between distance, rate, and time. Specifically, it says distance is equal to rate times time. And let's take a look at the final part of this problem. It says if it can go 15 miles per hour, well, that is a rate. Then how long? How long refers to time. Will it take to travel 40 miles in calm water? 40 miles is a distance, of course. So let's start plugging this in. We know that our steamboat is going to go 40 miles in calm water. And we know our rate is 15 miles per hour downstream. So right here, we've hit a little bit of a snag. We know that our steamboat is going 40 miles in calm water, but we're only given the rate of the steamboat as it goes downstream. So at some point, we're going to have to convert this rate of the steamboat going downstream to be the rate of the steamboat as it goes in calm water. So in the distance, rate, and time formula, I'm going to put a little star next to my rate to remind myself that I'm going to have to make a conversion here pretty soon. And of course, how long is what we're trying to figure out. So ultimately, we're going to be solving this distance, rate, and time formula for t. In other words, when everything's said and done, this equation is going to look like this. T equals something by itself. All right, so let's get back to this rate here, which we need to figure out to solve this one. You can see that there are 3 conditions in this problem, notably calm water, which I'll call C, uh, upstream, which I'll call U, and downstream, which I'll call D. And we know nothing about the rates of this steamboat in any of these conditions. So let's start with C. Since we don't know how fast this steamboat goes in calm water, we can say it goes X miles per hour. And if we work backwards, we can start filling in these other two. It says right here that it can go half as fast upstream as it could go in calm water. So if it goes X miles per hour in calm water, that means it goes 1/2 of X miles per hour upstream. And let's take it one step further. It says it can go 3 times as fast downstream as it can go upstream. Well, that means it goes 3 times 1/2 of X miles per hour downstream. And we can quickly work this out if we want. Again, we can place 3 over 1 to make it a fraction. And when you multiply fractions, you just multiply straight across. So this becomes 3 times 1, which is 3. 1 times 2, which is 2, and then we have that x there. So we know that our steamboat goes x miles per hour in calm water, 1/2 of x miles per hour upstream, and 3 over 2 x miles per hour in downstream conditions. Well, now we have enough to convert this 15 miles per hour downstream to be in terms of a rate for calm water, because we can write this like this: 3 over 2x equals 15. And if we solve for x, we'll know how fast the steamboat goes in calm water. So to do that, we're going to multiply both sides by the reciprocal of 3 over 2, which is 2 over 3. This will cross out here and here, leaving you with x over here. And again, we're going to write 15 as a fraction by placing it over 1, which means we can now multiply straight across. 15 times 2 is 30. 1 times 3 is 3. X is 30 over 3, which you should know is 10. So the rate of our steamboat in calm water is 10 miles per hour. And now we can go ahead and plug that into the distance, rate, and time formula. This becomes 40 equals 10t. Let's solve for t by dividing both sides by 10 now. This crosses out, leaving you with t on this side. 40 divided by 10 is 4, so t in this case is 4. In other words, it will take our steamboat 4 hours to go 40 miles in calm water, and the answer to that, of course, is D. So in case you didn't have enough yet, I included a bonus question in this practice test, and it says this: Michael, who is a stockbroker, earns a monthly salary of $2,500, as well as a fee of $100 for every trade he makes for one of his clients. How many trades must Michael make to earn $10,000 in 1 month? All right, so believe it or not, this problem's pretty simple. And the key to this one is going to be to translate this word problem into a simple equation that you can then quickly solve. So we know he earns a monthly salary of $2,500. So let's just write down 2,500. In addition, he earns a fee of $100 for every trade he makes. All right, so in addition to his $2,500 monthly salary, he earns $100 for every trade that he makes. And of course, we're being asked to figure out how many trades he has to make to earn $10,000. So the number of trades he makes is unknown. So we'll call that X. Again, in math, we represent unknown values with letter variables. So X is going to refer to the number of trades he makes. So that's going to be 100 times X. And of course, this is going to equal $10,000. All right, so clearly by solving this equation for X, we'll know how many trades he has to make to earn $10,000 in 1 month. Let's start solving this one by subtracting 2,500 from both sides of the equation. This will cross out here, leaving you with 100x on this side. And let's go ahead and work this out very quickly. 0 minus 0 is 0, 0 minus 0 is 0. 0 minus 5 we can't do, so we're going to have to borrow. We can't borrow from this 0, so we're going to have to borrow from this 1. This will become 0, this will become 10. If we borrow one more time, this becomes 9, and this becomes 10. 10 minus 5 is 5. 9 minus 2 is 7. So this becomes 100x equals 7,500. All right, we're trying to solve for x, so let's divide both sides by 100 now. This crosses out here, leaving us with x. And of course, we can cross out these corresponding zeros, and that leaves us with 75 over 1. 75 divided by 1 is just 75. So to answer this question, he has to make 75 trades in order to make $10,000 in 1 month. All right, so that is it for this video. As always, I hope you found it helpful. And as usual, you're more than welcome to leave feedback in the comment section below. If I had to rate these questions on a scale of 1 to 10, with 10 being the most difficult questions possible, I would put these questions at about a 7 or an 8. That said, if you answered most of these questions on your own correctly, then you shouldn't have too many issues when you take the actual ASVAB or PiCAT. Finally, I want to say this: if you want to help my channel out, you're more than welcome to subscribe to it. And on that note, I'll go ahead and cut you loose.
Konnichiwa.